On today's episode, fuel-agnostic engines, the death of diesel fuel? Today's episode is brought to you by engineering.com, a globally trusted source for engineering content. Check out this and many other exclusive videos for the engineering professional found only on engineering.com TV today. Trucks are important. In Europe and America, about 70% of all goods are carried on them, and globally, trucks account for approximately 1/5 of all global oil demand, about 17 million barrels per day. Now, the power source for those trucks is diesel fuel, a form of kerosene blended specifically for use in internal combustion engines. Diesel cycle internal combustion engines largely replace spark ignition engines running on gasoline because of the thermal efficiency advantages offered by compression ignition. Diesels can be 20 to 30% more efficient than gasoline-powered engines of similar power, but diesel fuel as an energy source is problematic. And the problem is in the exhaust gas emissions, where increasingly stringent standards, especially in Europe and the US, force after-treatment technologies that are so complex and expensive that they threaten the economics of diesel propulsion in heavy trucks. Alternatives include a return to gasoline spark ignition and cleaner-burning alternate fuels in diesel-type engines, but one company is hedging its bets with multiple options in the same power plant. The Venerable diesel engine builder Cummins has introduced a fuel-agnostic heavy truck engine that uses an interesting modular design to create a single internal combustion power plant capable of operating on diesel fuel, biodiesel, and gaseous fuels such as hydrogen, biogas, or natural gas. While hydrogen or biogas options can be either zero carbon or net zero carbon, the fuel infrastructure will be dominated by kerosene-type liquid fuels for the foreseeable future, and very strict ultra-low emission standards such as EPA Tier 5 and EU Stage 6 require extensive and expensive after-treatment technology involving complex catalytic reduction to reduce oxides of nitrogen, supplementary ammonia injection, as well as particulate filtration, which itself requires high heat regeneration cycles. Catalysts and filters are heated, and to address this power demand, the Cummins engine uses a 48-volt alternator to deliver increased current with moderately sized cabling. The technology is intended for both off-the-road and on-highway applications, with test 15-liter class engines going to Walmart later this month for field testing on natural gas. The engines will be produced at Cummins' Jamestown engine plant in western New York. With the widespread expectation of electrification replacing internal combustion engines, it's no surprise that Cummins, with a 50% market share in American commercial truck power plants, is fighting back with an internal combustion pathway toward lower carbon emissions. But the real push toward clean combustion may not be coming from CO2 emissions, but from the increasing costs of compliance with pollution control requirements. Historically, large trucking companies have purchased replacement engines ahead of emissions rule changes to defray some of the costs, and those high maintenance costs themselves provide an incentive to switch to cleaner burning alternate fuels, especially natural gas and hydrogen. Cummins is hedging their bets on hydrogen with the start of electrolyzer production at the company's Fridley, Minnesota facility. And what about the millions of Cummins diesel engines installed in consumer pickup trucks? Once durability tested on Class 6 through 8 commercial trucks, there's little reason to expect that Cummins won't target the big volumes that they currently serve in consumer brands such as Ram and Nissan. The diesel engine isn't quite dead yet. Well, that's it for today's episode of This Week in Engineering, brought to you by engineering.com. For our deeper engineering series, visit engineering.com TV for exclusive shows like Manufacturing the Future, Designing the Future, and the Engineering Roundtable, not found on our YouTube channel. The links are in the description below. Thanks for watching.